All right, what's up, everybody? Welcome, one and all. Thank you so much for joining us today for this episode of Model Monday Live, where we challenge you to take a 2D CAD drawing and turn it into a 3D model as quickly as possible. Try not to make any mistakes along the way, and ultimately earn points on the Model Monday Live leaderboard for proving that you are the fastest 3D CAD modeler out there, regardless of what CAD system you're using. This is a place where we get together every week with all the amazing 3D CAD enthusiasts that are out there, all the amazing members of the TooTallToby University. We got Mundane Superpower in the chat, says West Coast representing. Let's go, let's go. We got Rich Penn saying happy Monday from DFW. Yes. Uncle Facepound is in the chat. What's up, what's up? More greetings from Oregon from BZ Rocket. Let's go, let's go. And Guntus is here in the chat. What's up, my friend? Thank you for joining us. The Vicky Chong is holding it down in the moderator role. And guys, we got some awesome models for all of you today. We got some big news from the world of TooTallToby. Let's get this started. 45 Punk says, let's get this started. Serial South says, hello from San Diego. Hello, my friend. Great to see you here in the chat. Thank you for joining us on this beautiful Monday, March 9th. And what a beautiful Monday it is. Boy, the weather outside, you could not ask for better weather. It's sunny. It's nice and warm. It's not too hot. It's that perfect kind of spring weather. So I think we're getting pretty close to that 6 weeks from when the groundhog saw his shadow here in America, here in the United States. And that means that we are getting ready to head out of winter and head into summer, right? Or at least into spring. And I am very excited about that as well. Mark is here in the chat. Hello, my friend. Thank you, thank you, thank you. Or Mac. Welcome. Thank you for joining us. All right, let's get into it here today. As always, guys, please let us know if anything sounds out of line, if the audio is too loud or too quiet, if my voice is too loud or too quiet. I feel like my levels are just a smidge low today. I'm just going to try and boost my audio, my vocal a bit. Hello, hello, hello. Maybe I got to get right up in that microphone today. It's going to be one of those days, everybody. And guys, do we have any preference about what I use to do the live solve today? Should we use Onshape? Should we use SolidWorks? Should we use both? Should we use one for one and one for the other? Let me know in the chat what you want to see, and I will try to accommodate. So, guys, this is Model Monday Live. If you're here for the first time, be sure to let us know in the chat. What we do is we try to challenge all of you to take a 2D drawing and turn it into a 3D model as quickly as you can. And we also, of course, share some news about the world of TooTallToby, about the community, and give all of you a chance to kind of catch up with one another. And so today we're going to do 2 of these CAD speed modeling challenges where I'm going to show you a drawing and you are going to turn it into a 3D model as quickly as you can. And you're going to try to calculate the mass. Now, of course, we couldn't have this amazing community and this amazing show without all the amazing subscribers, anybody who's ever done super thanks, all the joiners, all the likers, all the tutorial makers, the super chatters, the value for value folks, the practice models premiums, the students that are out there, anybody who's shared the channel, the commentors, and of course, the Discord crew. We could not have any of what we have without all of you. So thank you all so much for being a part of this community. And I see Bill Black in the chat says, a Libre design would be an informative demo. Yeah, we'll have to bust out a Libre again. We haven't had that one doing the demos in a little while. We got to get that one back out. And they've been making so many amazing updates over at a Libre. If you haven't checked them out recently, be sure to check it out. BZ Rocket says Creo. Creo's one that I've never actually used, so I would have to. I could probably feel my way through. Once you're a CAD user, you're kind of you're always a CAD user. We're talking to some people who are helping us test out a new product, and one of the testers said to me, once you become a CAD user and you use 2 or 3 of them, you know how to use all of them. You can figure your way out through all of them. So always try to learn at least 2 so you can start to kind of spot the differences and the similarities. And after that, you'll see those patterns all throughout your CAD career. I thought that was pretty good advice. Dom is in the chat. Dom Linder says, hello. Hello, my friend. Welcome, welcome. Thank you all so much for joining us today. Don't forget to hit the like button. That's the easiest way to support the channel. Don't forget to share and reshare. Take a screen capture of what we're doing here at Model Monday Live. Share it out with your network. Even if you're just taking a picture with your phone and sharing it to your contacts, maybe your uncle or your aunt is really into CAD and you never knew it. It's always a great way to kind of roll the dice and see what comes up. All right, let's get into it here. We're going to do a CAD speed modeling challenge. I'm going to show all of you a 2D drawing, and you are all going to try to turn it into a 3D model and calculate the mass. And look at this. We got ourselves our first super chat, Mundane Superpower. Thank you, my friend. Wow, $10 coming in hot. Thank you, thank you, thank you. That is awesome. Wow, really appreciate that on this beautiful Model Monday Live. It really is a beautiful, listen, we're winning already here in the chat, and I got to tell you guys, we just came off of a weekend of just winning. It was such a good weekend. My youngest son, his soccer team played on Friday night. They won their game. Then on Saturday, Vicky and I and our daughter is a member of a scout troop, and they did a first aid meet, and they won the first aid meet. So it's just been winning. My older son got into his #1 college of choice. So it's been an absolutely beautiful weekend, and the streak just continues. And you just want to remember, this is my lesson. I'm not trying to brag or gloat or anything, but what I will say is this is something that I've learned over the years. Luck comes in streaks, all right? And when you're on a bad streak of luck, batten down the hatches a little bit and try to kind of move a little bit slower and try to compound those mistakes, because luck is already working against you. A lot of times these bad luck things come in threes. And so the first bad luck thing happens, you knock a coffee mug off of the counter, make a big mess when you're already late. Then the second bad luck thing happens, you get stuck in traffic or get a flat tire or something like that. Well, that's a great time to kind of batten down the hatches and realize that there's going to be a third thing that's going to happen. Okay, so don't get stressed. If anything, get looser and kind of be a little bit more go with the flow, because something is going to happen. Usually these things come in threes. But that streaky luck also goes the other way. And sometimes when things start breaking in your favor, that comes in a big long streak too, or a big long wave too. So try to maximize that, try to really enjoy that. Reach out to people maybe you haven't talked to in a while and try to rekindle those friendships, and just really try to maximize that luck, because that's really what will make a big difference. It's surprising, but sometimes that can really make a difference. So luck is streaky. That is the TooTallToby philosophy lesson of the day. And I want to say thank you so much to Uncle Facepound coming in with a super chat as well. Thank you, my friend. That is awesome. Awesome. Thank you. And Bill Black, thank you, my friend. A super chat from Bill Black as well. Wow, welcome, and thank you so much. That is awesome. Let's go with the super chat train. We love it. Thank you all so much. I'm glad you guys are enjoying the channel. I'm glad you get a lot out of this, and all of these donations, they all go right back into the company to try to help us, keep the exciting enhancements coming. So, guys, on Model Monday Live, we're going to show you a 2D drawing. You're going to try to calculate the mass, and then you're going to try to enter that mass directly into the YouTube chat. BC Rocket says we got our philosophy lesson early today. That's right. You got it exactly. That is right. Super chats come in 3. Nice. Yes, exactly. Straight up Kiki says super chats come in 3s as well. Yes, exactly. That's awesome. Bill Black says that's for your son's success. Good colleges aren't cheap. Yes, indeed. Very, very true. All right, guys, so after you calculate the correct mass, you're going to enter that directly into the YouTube chat. But the thing is, the only way you're going to get the mass correct is if you know the density of these parts. See, mass is calculated by taking volume times density, and if you don't have the correct density, you're not going to get the correct mass. So make sure you've got these material densities ready to go. You can do a screen capture. You can do a print screen. Make sure that you're ready to go. Make sure that you've got all the correct densities in here. And Jay Vivek is here. Welcome, says hi. And FPV Kev is here as well. How are you on so early? I literally just got in. Yeah, daylight savings messed us all up this weekend. Everybody was kind of a little off kilter yesterday. Even with the weekend of winning, we were still a little bit off kilter yesterday, and it kind of continued into this morning. But we're getting back on track. So welcome, FPV Kev. It's probably why, Vicky, it's probably why we didn't have as many people here at the start of the live stream, but I think they're going to know. Reach out to everybody in your network. Let them know that we've started. Here's how this is going to go. You can use any 3D CAD package. Make sure when you answer, you use the specified precision, and the first person to answer correctly in the chat will be declared the winner. So good luck to everyone here, and let's go into our first challenge. If you win, you're going to earn a point, a coveted point on our Model Monday Live leaderboard. Last year, the first place winners had 19 points each, so it's really still anyone's game. But we see it's Mr. Misha up top here with 5 points so far. Let's see if he's going to get his first point today during the month of March. And, of course, the advanced rules are this is meant to be fun and good-spirited. Occasionally, I will make mistakes, and the Ivan exploit is permitted. So let's go into our first challenge. As soon as we show this challenge full screen, the challenge will be live. You're going to start modeling, and then you're going to answer directly in the chat for the first half of the show. So here we go in 3, 2, 1, go. And so the question here is, what is the mass of this part in xx.xx grams? The tolerance is plus or minus 0.05 grams. And we can see here that the unit system is MMGS and the material is ABS with a density of 1020 kilograms per cubic meter. This part is called plastic rail bracket. And I really like this part. I actually use this part in our other new system, which is for STEM educators. We've got this this part in that library as well, because it really does a nice job of illustrating the importance of deciding which face should be down when you do 3D printing. And we'll talk about that a little bit here as we get towards the end of this challenge. But take a look at this challenge, see what you can come up with. I'll give you guys a live solve of this one. I think maybe I'll live solve this one in Onshape for all of you. So I'll give you guys a live solve of this one in Onshape, and then we'll take a look at the other challenge. Maybe I'll do the other challenge in SolidWorks, or maybe vice versa. Maybe I'll do, I don't know, maybe I'll do this one in SolidWorks, and I'll do the other one in Onshape. So give this thing a go. Grab a screen capture. We're not going to leave it up on the screen much longer. If you're here for the first time, just understand that we only leave the challenge up there on screen for a little bit, and then we're going to take the challenge down. And we're going to keep talking about what's going on. I'm opening up a model here, and I ended up getting an error when I was opening up the model. So that's what, if you heard that ping, that was me opening up something in SolidWorks that I want to show to you all in just a few minutes. All right, I'd print it on its side, so probably just a little support for the holes. Yeah, you can print it. You actually don't need any support on most printers, depending on how important the trueness of the whole cylinder is. It technically probably, if you didn't print it with support, it would be a little bit of an oval, but for this application, it'll work fine. If you're using machine screws or if you're using wood screws, you'll be fine for this application. So FPV Kev says, yeah, I'd print it on the side. Yeah, and that's exactly right. I mean, the thing is, let me bring up, maybe I'll talk about this at the end. Maybe I'll do the live solve now, and then I'll talk about this at the end. Or maybe I'll do the live solve now, and then I'll talk about this at the end. I think that's how I'm going to do this. Let me just open up one more thing here. I wonder if I have this in here already. I do. All right, cool. So we'll talk about this in just a little bit as well. Look at Hassan coming in with an answer already. Yo, that is impressive. That is fast. Man. We might have some new competitors here in the next tournament. Dom was behind him by about 2 seconds, but guys, we're already seeing answers in the chat. How cool is that? How cool is that? So this is a model that you can model up. I'm going to model it up in Onshape here in just a couple of minutes, but I think, or maybe I'll model it up now. I'm shooting a little bit from the hip here today, guys. You can probably tell. Shooting a little bit from the hip, but maybe I'll just model this thing up now. Let's just model up now and see what happens, right? So let's bring up Onshape. I'll bring up Onshape. I'll bring up my keyboard cam. We can look at this thing together. I'm going to choose to create a new document, and this document is called 26-13-17 plastic rail bracket. Wait, what did I say? Oh, no, I think I said I was going to model this one in SolidWorks, right? Yeah, we're going to model this one in SolidWorks. All right, here we go. We'll model it up in SolidWorks. So 26-03-17 plastic rail brackets made of ABS, 1020 kilograms per cubic meter. I think what I would probably do here is I would grab a screen capture, but I think I'm just going to move it off to my second screen so I can keep an eye on it. But before I start 3D modeling, I always think it's important to come up with a game plan. So if you're going to come up with a game plan for this part, I think what you would want to do is, first of all, identify where your origin is going to be. Now, this part has centerline symmetry in 2 directions. So basically, anytime you've got centerline symmetry in 2 directions, the origin is going to be the intersection of that centerline symmetry. And then the other thing you're going to do is you're probably just going to plant the origin down here flat, the way this part would mount up against the wall or mount onto a table. So centerline symmetry is going to allow us to identify the origin pretty quickly here. Now, the next question is going to be, what's our first sketch going to look like? And for this model, because this model has this 3mm wall thickness, I'm going to take advantage of that, and I'm going to create my first sketch to simply look like this: a line over, a line up, a line over, and then a construction line here in the center. And then I'm going to add in these dimensions using the double dimension functions in SolidWorks. And then once I've got those dimensions in place, I'm going to extrude the whole thing using the thin feature option. And that's going to extrude with a wall thickness of 3 millimeters. Now, I am going to extrude it mid-plane and extrude it out to a depth of 35 millimeters because I don't think there's really that much of an advantage of like just doing one quadrant and then mirroring and mirroring twice. I think you're probably fine just doing 1/2 and mirroring the whole thing at the end. So after I've got that geometry in place, then I'm ready to start defining the location of this hole. And in SolidWorks, when you use Hole Wizard, what you would typically do is you would either create a construction line that would go all the way across and make that 25 with a midpoint relationship, or you would just draw a vertical line and then add double dimension like what we talked about earlier. I'll probably do it with a construction line horizontal and then make that 25 and then make it midpoint. I think I can blast through that workflow a little bit faster. And that way then I can just drop that point on the end of that construction line and boom, we're done defining the location for that hole. We'll just go through and use the hole settings to control these settings here. And then the final thing I'll need to add in at the end here is going to be that chamfer. So the chamfer is called out here in the front view. Right here, chamfer 1.8 by 45 degrees. So now that we've got our game plan, we can move this over to our second screen. And like I said, I think I'm going to do this one in SolidWorks. So let me just start a new document here in SolidWorks. This is going to be using my ABS template, and let's give this thing a rip and see how fast we can get through this thing. So I picked a template. When I chose new there, I said I wanted to use a new template. This template is in ABS, so I don't even have to assign the material or anything. Front plane, begin a sketch, S key, line, single click, move my mouse over, move my mouse up at an angle, move my mouse over, S key, construction line, vertical line here, S key, dimension, create a dimension that goes from this point to that construction line and cross over 58 millimeters, from this point to the construction line, cross over 42 millimeters. And then I need to add in my angle dimension here. And for the angle dimension, you can hold shift, and that'll let you get a doubled angle dimension when you're doing something like this. Now for our final dimension, we're just going to go for max height here. So from the top one to the bottom one there, 29. And now we're ready to take that geometry and turn it into an extrusion. So there's going to be a thin feature extrusion, 3 millimeters for our thin feature. And I'm realizing now that I forgot my fillets. So let's make this go out to a depth of 35. Let's right click in the background and say mid plane and then right click again. And let's get back into that sketch and not forget our fillets. So sketch fillet here. Sketch fillet's going to have a radius of 5 millimeters, and that's going to be on this corner and this corner. And we're going to say keep constrained corners so we don't end up losing our dimensions. So now that we've got that geometry, now we see that our extrude looks a little bit cleaner. Looks like I made that 42. I should have made that 36. I don't know why 42 was in my brain. And now we're going to go to this surface here, begin a sketch, normal 2 there with control 8, single click, move our mouse, single click, or don't single click, type in 25, enter, hit escape, pick this point, and then make those midpoint. And then that's going to set us up with a perfect location for our hole wizard. So we can pre-select this face here and we can do hole wizard. Now I know I could have sketched that geometry in the hole wizard, but sometimes it's nice just to have that geometry kind of out on its own standalone. And now this is going to be a countersink here. So we're going to make this a countersink, and then it's going to be anti-metric flathead screw. And if you say show custom sizing, you can see this actually is the correct sizing for an M5. I did look this up independently outside of SolidWorks. I know that they always say that SolidWorks uses the machinist handbook to define their sizes for Hole Wizard, but I did look it up independently just to confirm. If these weren't correct, what you could do is 5.5 tab, 10.4 tab, 90, enter, and then we've already picked the position, so we can just hit the green check mark and we're done with that hole. And then the final feature that we're going to add in here is going to be the S key chamfer and 1.8, enter, and then single click on this edge here, right click, okay. And now we're ready to mirror this thing. So for mirror, we can pick this body here out of the tree. We can pick the mirror plane, and then we can let go of control, and we've got mirror here in our context toolbar to kind of speed along that process. We've got a sensor here in our tree, so we can do a control Q, and we're coming up with 12.13 grams. Let's go into the chat. 12.13, enter, and we'll see how that holds up against some of the other chat pros as we continue to go through today's presentation. A little bit of a speed run there. I went through that one a little bit speedy, but I like that one. I like that model. I like the fact that, you know, when you, like I said kind of at the beginning, when you 3D print that model, you really want to be conscious of where the stresses are going to be applied. Like, where do you anticipate stresses on this model? Well, the fact that it's got the chamfer here and the fact that it's like tilted in going up tells me that there's probably going to be something that's oversized that's pushed through and that kind of locks into place there. So if you know that it's going to be bending, if you know that it's going to be stressing outward in these directions on these tabs, you want to be careful about printing this thing flat. If you print this thing flat, and if there are any, if I do, I just want to preface this by saying that I'm much more of an expert in SolidWorks than I am in 3D printing. So if I am missing a little nuance here and you care to elaborate, feel free to type into the chat. But basically what happens here is that if we do print this thing flat, each layer is going to generate a layer line. It's kind of like each layer is almost like a sheet of paper that gets glued together. I mean, really, that is what it is. It's like a sheet of plastic that gets adhered together because it's melting. So you can see here the preview of what this is going to look like. We're going to lay down one layer, then another layer, then another layer, then another layer. Well, if you're printing it this way, then you end up with these different layers. They will be more likely to unadhere or to break ultimately at that location. So when you end up applying stress there along that corner, you're creating a weak point if you print it like this. Now consider if you were to layer adhesion versus material strength. Yes, exactly. Thank you, straight up Kicky. I'm trying to learn some of the more like official terms here as I'm trying to explain this. I kind of am like I learned it on the street, so I know what breaks and what doesn't. Yeah, like I think delaminate. I grew up skateboarding, so I'm like, oh, this thing's just delamming. That's great. So but that's great. Layer adhesion versus material strength, exactly. So if before you go to use your slicer, before you go to send that over to the printer, if you flip this thing at 90 degrees. So now if we look at the slice preview, now what we're going to see is that basically each cross section is this shape, and each cross section is taking that shape and creating additional strength where those bends are going to be taking place. And so if we go into the slice preview now, we look at this thing and we go down through here, you can see here that now each cross section is that entire shape. And so we're not, it's not going to be any weaker. In fact, it's actually going to end up being stronger. And that's why I really love this model. That's why I wanted to include it today. And I also have included this in our new library that we're building for STEM educators, because I think it does such a nice job of illustrating that. And I think it's so easy to visualize it, especially when you see it in that first example where you kind of see the layer lines stacked up. All right. And BC Rocket says, oh yeah, OG flash print. Let's go. Yeah, I haven't updated my flash print in quite some time. That's for sure. I'm still rocking an old Inventor 3. So, but it does the job, man. It really does the job. Does it slowly, unfortunately. That's the biggest reason that I'll use some of the newer printers. It's just like, I look at the print time on something like this. I'm like, an hour and 14 minutes? Really? Like, that seems like really long compared to the newer printers, but it doesn't have the right nozzle to do high speed. So, still happy with the results. But yeah, you know it. Crispy Co knows his stuff when it comes to printing. Oh, that's cool. Maybe we can get Crispy Co on here and do like a little Stump the Chump type thing where we can take some questions from the audience. That would probably be a great episode. The Vicky Chong in the chat says, interestingly, my chat is not showing all the messages. Maybe change it to live chat instead of best chat or whatever. There's a setting in YouTube where you can filter that. Uncle Facepound says, well, I found my problem, revising to 12.12. Nice. All right, listen, guys, we're going to speed run some of the other news in the presentation for today because we got a lot of good stuff to talk to you about. And then the second challenge is a little bit of a heavy challenge. So I want to make sure you have enough time to work on that as well. So you guys can keep answering for this one. Don't forget to hit the like button, share and reshare. Let people know what we're doing here at Model Monday Live. It's a lot of fun, even during daylight savings. Tell one coworker about the channel. And if you really like these types of challenges, you can sign up for Practice Models Premium over at TooTallToby.com, and we'll talk about that in just a little bit. We also are celebrating the 300 Club, now the 300 plus 1 Club. So these are people who are on the website who have done 300 or more models, 300 or more CAD challenges. So congratulations to all of these people. It's more or less random who gets the number 1 spot. They're really all technically tied, but SWEIR 1 million is in here as in the number 1 spot. Congratulations. Or 10 million, 1 million, 10 million, 1 million. So congratulations. Well done. And congratulations to everybody who's got 300 plus 1, and special shout out here to Matab, who also has 300. Let's go. So awesome to see all these different users from all these different countries. Love seeing Jim U. Kerberos in here rocking FreeCAD. Love seeing M. Vince in here rocking Creo. And of course, I love seeing all the Onshape users in here. Also, we've been releasing the the Power Moves video this year. We've continued with the Power Moves series, so if you are a SolidWorks user, make sure you subscribe to that. Party Pack Volume 3 is now available for purchase. If you like having these challenges, but you prefer to have them standalone, you can purchase Party Pack number 3. Little news about our friend Matab. We just mentioned Matab a moment ago, but not only is he a member of the 300 Club, he also recently won the title of champion in the solo national CAD competition at Celestra 2026. So yeah, put a 1 in the chat for Matab. I don't know if he's here, but if you see him in the chat, if you see him in the Discord, or if you see him in here in the future, huge congrats to Matab. You can also look him up on LinkedIn and give him a shout out there on LinkedIn. But this is not the first competition he's won. He's also won the TooTallToby tournament. I wasn't thinking of that, but he's also won the TooTallToby tournament. But he's also won several other competitions, and he's a fairly new CAD user. I think he said he started in 2024. So he's a pretty new CAD user, and he's just absolutely tearing it up. And it's always good to see him in here. It's always fun to watch his speed runs. And got to give a shout out to Matab, a regular in the TooTallToby community. And guys, in the world of training, if you are trying to get better at SolidWorks, if you want to be like Matab, who's a SolidWorks user, you can check out our Zero to Hero Challenge. Go from complete novice to certified SolidWorks professional in 30 days. We have the path for you. TooTallToby.com/training is the website. Check it out and enjoy. And if you ever need custom training with TooTallToby, you can reach out Vicky at TooTallToby.com. We're also in the second half of the show. We're going to use the Practice Models app. So you got to go to TooTallToby.com and sign up for free. TooTallToby.com. You can get started for free. And then once you get started for free, you'll be able to access the library, the full library, but a lot of them will be blocked. But you can access the free challenges. And more importantly, for today's challenge, you can access this area up top here, which we call our featured challenges. And so in this area up top here, we've got the 3D printed, I thought you guys would think this is pretty funny, the 3D printed bolt and nut, which I just kind of went crazy with over this past week, and I just kept printing them in different colors. And then these are now like not only a fidget spinner tool, but I have them clamped to my 3D printed phone stand. So I just going crazy, having fun with these. But guys, if you haven't printed one of these, print them, cycle them. If you put like 10, 20 cycles on that nut, it really starts to spin quickly. It makes a great fidget toy, and it's cool. It's because of the tolerance and because of kind of the give of the PLA, it starts out misaligned. It starts out misaligned by about maybe 10, 15 degrees. And then the more you use it, you kind of break in those tolerances. You can almost get the nut to be perfectly aligned with the head when it's totally engaged. So it's just kind of a fun fidget toy and something you can print out, give it to the kids, and let them play with it as well. Those 2D to 3D drawing challenges are available. I'll probably leave them up there for another week, the hex bolt and the hex nut. So you can draw that up yourself, and then you can print out a set. And let's go on here, continue on. I know I said we're speed running this. We do a lot of cool practice models every month, every week. We release new practice models to the library. So if you do upgrade to Practice Models Premium, you'll get access to quite the variety. This is one that I released in February. It was 4 parts, and then you could 3D print it and make this kind of ratchet mechanism. It was some fun. So we get lots of cool stuff in practice models, but guys, pay attention. We got something new coming. User-created CAD challenges. Have you ever been out there watching this show and you have wanted to upload your own challenges? Well, guess what? We've got the TooTallToby beta sneak peek here. You can see this is our friend Casca. He's in the chat right now. Guntis. Casca was the creator of this challenge, and anybody with Practice Models Premium will be able to do this challenge. So we're going to have user-created CAD challenges here. They're going to show up in the library just like the regular TooTallToby challenges, but we're going to have a special section for the user-submitted challenges. And we've been going through beta testing it over the past about the past week. We're going to keep testing it probably for another week, and then before you know it, we're gonna have this library of this monstrous library that people are uploading their own challenges to, and I can't wait to see it. I can't wait to see what people come up with, and I can't wait to kind of challenge myself and speed run some of these myself. So it's gonna be really far. I can't wait. I think you're missing one in front for that. One in front. As far as the tier on that challenge, I think you're missing one in front for that. I'll have to see what I'm not sure what you're referring to there, Uncle Facepound. If you want to elaborate, if you're talking to me, you might be talking to somebody else in the chat. All right, guys, if you want to sign up for Practice Models Premium, head on over to TooTallToby.com. You can upgrade to Premium. It's the best $5.83 you'll spend per month. It's the best way to learn. And we couldn't do any of that without our amazing team of Bodie McBoatpants and Hoobie 3D FX. And thank you guys so much for always supporting. Oh, I see. You're saying, yeah, maybe tier 4 should be a tier 14. Nice. All right, guys, and in the second half of the show, we're going to judge the winner based on the TooTallToby app. So you do need to have a free membership at TooTallToby.com. What we'll do is we'll show the drawing here in this library, and then once we show the drawing, we're going to use this tool here, the first 42, which lets us know how fast someone finishes the challenge from the time it is released. So that's it for our news. Check us out on Discord if you want to hang out with us a little bit more. And, the final thing I wanted to mention, I know I've mentioned this a couple of times, but this challenge that we're doing right now, this orange bracket, this is also going to be found in our new STEM education platform, where we're kind of going from beta into pre-release here of a new platform for educators, for STEM educators. So we've got classroom management tools. It's very similar to TooTallToby.com. It's CAD challenges, but the educators have the ability to assign those challenges to the students. It actually factors in competency-based learning. So what skills are they actually learning to complete these challenges? And of course, we've got a lot of student data privacy tools that we don't have, or at least don't have yet, in TooTallToby.com. So and those are things like the students can't upload their own user icon. They pick from a library, things like that. We obfuscate the student names, things like that, to make sure that the students are, that their data privacy and that their privacy is protected. So that's something that we're really excited about. You're going to hear more about that. Like I said, we're going to transition here from beta to pre-release probably over the next couple of weeks. So you're going to hear more about that. But if you are an educator, or if you know somebody who's a STEM educator who would really benefit from having like a digital workbook of these 2D to 3D CAD challenges, be sure that they reach out, Vicky at TooTallToby.com, and we will get you all the information you need to get started and to hit the ground running. So Vicky at TooTallToby.com, and be on the lookout for that. All right, that is all for the news. Be sure to hit the like button. Be sure to subscribe. Be sure to share and reshare. And we saw these answers coming in really quickly on this one. We already talked through the game plan. We actually showed what I did, the way that I went through and did it. So the only thing left to do now is to figure out who came up with the first correct answer. And boy, those answers came in quick. But it looks like the first correct answer was possibly here from Hassan, 12.13. Tom, 12.13, very nice. Mundane Superpower, 12.13. BZ Rocket, 12.13. Uncle Facepound, 14.387. Guntis coming in, 12.13. Uncle Facepound revising, 12.24. I like it. And let's see here. Uncle Facepound revising further, 12.12. I like it. And let's see here what else we got. Some ones in the chat there from a tab. All right. What is the correct answer? The correct answer is 12.13 plus or minus 0.05 grams. So if anybody got that, or even got it within tolerance, congratulations. That is not an easy part, but it looks like our first point is going to go to Hassan. So guys, put a GG in the chat for Hassan. Well done, my friend. And we're going to start getting the next challenge ready here. Make sure that we've got this next challenge ready here for everyone. Let's see here. And let's see here. Make sure we've got this. Give me 1 second, guys. We're going to be getting that next challenge ready. Put a 1 in the chat. Put a GG in the chat for Hassan. First point, I believe, Hassan. If I'm right, let me know in the chat as well. I think that's the first time I've seen you earn a point here on the leaderboard. So well done. And let me just take a look here. Make sure I don't type this in wrong. All right. All right. And then the final thing here is this guy. You guys are going to be challenged on this one. There's a lot of tools in this one that you're going to be challenged on. All right. And here we go. So what we're going to do here is we're going to show everyone the next challenge, and basically at the same time, we're going to release it onto the website here at TooTallToby.com. The thing is, when everybody from the chat is trying to hit the website at the same time, and there are lags because of coming from different locations from around the world, it's a little bit unfair if we're just relying on that release on the website. So to make things fair, what I'm going to do is I'm going to show you. Well, let me move the chat there. I'm going to show you the challenge here on the live stream. I'm going to show you all the challenge here in the live stream, and that way we'll all see it at the same time. And then you're going to jump over to TooTallToby.com maybe once you're done modeling it or in the middle of modeling it or whatever. You're going to jump over to TooTallToby.com, and when you go in here to the library, there's going to be a new challenge here in the practice models in the featured models section, and that's where you're going to enter your answer. So we're going to track how long it takes. We're going to release these at about the same time, but again, to kind of keep it fair for everybody, we're going to show it to you here in the live stream. Sound good to everybody? If you guys are all ready, I am ready, and good luck on this challenge. I think this is going to be a really fun one, and it's got kind of a fun backstory too, which I will share with you as well. So here we go. We're going to flip over to full screen, and this next challenge is going to go live here in, whoops, let me bring up my, whoops, that's not what I wanted. Okay, here we go. This next challenge is going to go live here in 3, 2, 1, go. And so the question here is, what is the mass of this multi-body part or assembly in XXX grams? The tolerance is plus or minus 1 gram. For the material, it says, see the bill of materials. For the density, it says, see the bill of materials. So it looks like we've got 10 wooden spheres that are made from American cherry. We've got 5 bent hooks that are made from plain carbon steel. And we've got 1 rear support that is made from plain carbon steel. This thing is called the coat hanging rack. Oh, I think I named it wrong in the platform. I think I called it hanging coat rack. But either way, it's a coat rack that hangs on a door. There are 2 additional sheet metal brackets that are not shown here. So it's hanging from the door, and it's hanging from the door. It's hanging from the door, and you hang your coats on there. So it's a coat hanging rack. And you can see here that what would probably happen is that in the upper left, what would probably happen is that the tips of those rods for the hooks, that those tips would probably be threaded, and then the hole that's in the ball would probably be threaded as well. Or those tips would just be a little bit smaller, and then you just dump in some adhesion in there, some Gorilla Glue maybe. Vicky loves it when I use Gorilla Glue on projects around the house. But you would put something in there to adhere, to either thread or adhere those balls onto those rods. So you'll notice that the ball has a hole in it. You'll notice that the rods have a little bit of a smaller area up at the ends, and that's for all 10 of those ends of the rods. There's 5 or hooks, excuse me. There's 5 hooks, and each hook has 2 ends. So there's 10 ends, and all 10 follow that same layout. This is a fun one. Electro Shinu says, yo, boys and girls. Welcome, 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 my friend. All right. Guys, good luck, good luck. This is a really fun one. And the chat always gets quiet at this point because everybody is trying to model this thing up. This is a cool, very cool model here. And what I'm going to do is I'm going to turn off full screen, and I'm going to go back to Onshape, and I'm going to do a live solve here using Onshape. So make sure that you've got a screen capture of this thing. It's an interesting one. There's one little Toby trick in this one. Rich Penn will like that there is one little bit of a Toby trick in this one. Not too tricky, but a little bit tricky. It might catch up a couple of people. But for the most part, everything's dimensioned to the center lines. There's that 64.5 over on the right. That's to the center line. It's because of how that radius is coming down on the back of that part. It does tend to look like it's hard to tell if it's on the center line or not, but it is. Everything's on the center lines. All right, and with that, let me go back to my webcam, and I think we're ready to turn this thing into a live solve. And so the way that we're going to do this is we're actually going to do this here on the platform, on TooTallToby.com. Now, we utilize these things called the featured models, and the featured models are models that we release every week, and we kind of leave them up there for about a week, and they're free for everyone with a free account or a paid account. So it gives you a chance kind of every week to whet your appetite a little bit to see if the TooTallToby platform is a good fit for you. And one of the ways that you can do that is by doing some of these challenges. Well, those featured models are sponsored this week by our friends over at Xometry. The thing is, the Xometry code has changed. It's now Toby20 Spring. So I just wanted to bring your attention to that. The February code has expired, and now we have a new code, Toby20 Spring. And so if you want to save 20% on your first order from Xometry, you can use that code. All right, let's get into it here with the 3D CAD live solve. We're going to start out by going to TooTallToby.com. We're going to sign up for a free account, and then we're going to click here where it says Access Full Library. And once we do that, once we access the full library, we can see that there's a library of challenges here. Some are only going to be available if you're a paid customer, if you're using Practice Models Premium. Some of them are free. And then up at the top here, every week we cycle through some featured challenges. And this week we've added a brand new feature challenge. We just added it a few moments ago. And so we're going to be utilizing the featured challenge here from this. Oh, you know what? Oh, man, I think I might have made the mistake again, Sal. Hold on a second. Let me fix this real quick. Just realized something. I mistyped a number in here. Hold on. Let me fix this real quick. I mistyped a number, guys. I'm sorry. Okay. I think I fixed it, Sal. Refresh here. Make sure that it's working. Thank you for that heads up. I think it should be working now. There might have been something that happened to me on my end. I mean, we'll see here in a second when we get into the challenge. But it looks like it works and it's refreshing here. So, all right. So welcome everybody to this episode of Model Monday Live. And we're going to do a live solve here using Onshape. And so to access this live solve, we're going to go to TooTallToby.com. And when you're on TooTallToby.com, whether you've got a free account or a paid account, you're going to see that there are some challenges up at the top here. New challenges we add every week. And these are called the featured challenges. And users with a free account can experience all the capabilities of premium membership. Thanks to this week's featured challenges sponsor. And this week, our sponsor is Xometry. You can visit them at Xometry.com and save some money off your first order. And so the challenge that we're going to be doing here is called 260302. And this is a brand new challenge that we just added to the library a few minutes ago. So everybody in the chat here at TooTallToby.com is trying to solve this thing. And I'm going to try to solve it right along with you. So we can see here that the skills that we're going to be tested to solve are going to be multi-material patterns, revolve, sweep, and symmetry. So let's get into it here and see what this thing looks like and see kind of, what we come up with as far as a solve strategy goes. We're going to begin this challenge here in 3, 2, 1, go. And so we can see here that the challenge is a multi-body, a coat hanging hook or coat hanging rack, excuse me. And we can see here that there are 10 wooden spheres, 5 bent hooks, and 1 rear support. So we start out with a bill of materials up here in the upper right. And it says, what is the mass of this multi-body part or assembly in XXX grams? The tolerance is plus or minus 1 gram. So as always, if you want to have the most success in the world of 3D CAD, what you need to do is you really need to start planning out your models. And one of the first things you're always going to ask yourself is, where should the origin be located on this model? Now, for me, I think that the location of the origin, it's hard to tell in this one because usually I base it on where there are several dimensions coming from. And there's not really necessarily a spot where several dimensions are coming from. I mean, certainly the model has symmetry down the middle. So I think it's a safe bet that the origin is going to be somewhere along this line here. But then the next question is, where's the origin going to be in the other direction? So I think without really kind of having an obvious starting point, what we can then look at is, are there any models in this part here that are pretty easy to create and anchor down? And I think that the model that stands out to me the most that's easy to create and anchor down is this model here, the kind of rear support. So I think what I'm going to do is I'm going to create the origin right here. The reason I'm choosing the lower part of it versus the upper part of it is just because we have this 1 extra dimension that's coming down from the lower part here, this 18 millimeter dimension, and then we have this 124 that's anchoring off of that dimension up to the top. So I think that my origin is going to be located here, and I think my first sketch is going to look something like this. But because this model has symmetry, I might consider drawing the whole thing. I might consider just drawing half of it. I'd want to think about it for a second and ask myself, is there really going to be a benefit of just drawing half of that part? Because, the next thing that I'm going to do is I'm going to create one of these hooks. That's going to be 3 parts together. And then I'm going to do a pattern, and that's going to be a part pattern. And I'm going to use the option for centered in Onshape. So that pattern's going to go both directions. So I don't really think there's much of a benefit of me just modeling half. So I think that my first sketch is going to look like this. Maybe I could even use a slot here. We love using the slot command in Onshape. So maybe I could even use a slot here as my first sketch. And that sketch is going to be my sweep path. And then my second sketch is going to be a circle over here with a wire diameter of 5 millimeters. Oh man, I think I might have missed a dimension on this. Did I miss a dimension on this? Did I not call out the wire diameter anywhere? Oh, guys, the wire diameter is 5 millimeters. Oh man, I'm missing a dimension on this, guys. I apologize. Yeah, the wire diameter is 5 millimeters. Wire diameter is 5 millimeters. Guessed 5 and it worked. Yeah, Dom, thank you. Yeah, wire diameter is 5 millimeters. I apologize, guys. It's for both the wires. All wires, diameter is 5 millimeters. I'll fix it on the challenge on the website here as soon as we're done live streaming, but the wire diameter is 5 millimeters for everything. So 5 millimeter wire diameter, and that's going to be everywhere. So like this diameter here is 5 millimeters diameter. Missed a dimension. Wow. Hey, occasionally I will make mistakes. So 5 millimeter wire diameter for this thing. And so what I'm going to do here is I'm going to create my second sketch on this plane here with that 5 millimeter wire. And that way I can do a sweep of that kind of rear shape. And then I think what I'll do is I'll jump onto my right sketch plane. And for my right sketch plane, what I'm going to do is I'm going to sketch this hook here. So I'm going to create this shape here. Now this is where we have a little bit of a gotcha. And the gotcha is, what is the height to this point here? What is the height to this point here? And so we have to kind of return and look back at this view to determine what that height should be. But I think it's pretty easy to realize that that's what's going on because of how close those dimensions are. So it's not super tricky, just a little bit tricky. You know, you kind of get zoned in on one view. You might think that there are some dimensions that are missing. So once we create that sketch there on the right side view, we can once again sweep a 5 millimeter diameter circle along that hook. That'll give us the geometry for the hook. And then once we're done with that geometry for the hook, what we can do is we can get in here and we can create this little sleeve at the tip of the hook, and that's going to be at both ends of that hook. And then once we've got that little sleeve there, we can create the geometry for this for the wooden ball. I think what I'll probably do for the wooden ball is I'll probably do that as a revolve, because that way I can include the hole in that one sketch. I can kind of create a reference to that other part, but I can also include that hole in that one sketch and just kind of get that whole thing taken care of. So in other words, when it comes to creating this ball here, I think what I'll do is I'll create a shape that looks like this, down over like this, and then swing that around and then revolve that shape to give me that wooden ball. Once we've got that, we're ready to turn this thing into a pattern. And like I said, I'll do that as a part pattern, and I'll use the Onshape option for centered so that it goes in both directions with that 96 millimeter spacing. So now that we've got our game plan, you know, I know I took about 5 minutes to come up with a game plan there, but I think it's always important to come up with a game plan. And if you agree, be sure to hit the like button on this video. And now that we've come up with that game plan, I'm going to say open in a new window. I'm going to move this over to my second screen. I'm going to take this and move it over here so we can all keep an eye on that clock, because we are going to be speed running this a little bit. I mean, the speed run kind of occurs naturally because we've got that game plan. We've got such a good game plan. And then let's bring up Onshape here. And let's create a new document. We'll call this 26-03-02 coat hanging rack. Okay, and that way, if you guys get stuck on this model, I am going to store this in the public space. So if you get stuck on this model, you can just search for this text, and then you can open up my model, copy it into your workspace, and then you'll be able to kind of poke through my history tree and figure out what's going on with your model. So I'm just going to move this over a little bit here so we can still see the clock, and let's get into it here. Let's follow our game plan. So I know because my because my account utilizes a default workspace unit of millimeters and grams, I'm pretty confident that I'm in the correct units. So I'm going to go front plane, begin a new sketch, N key to get normal 2. Let me bring up my keyboard cam so you can see my shortcuts. So N key to get normal 2 here, and then I'm going to do a sketch a line like so. I'm going to hit escape. I'm going to click on that line, and here in the offset menu, I'm going to choose slot, and I'm going to give that thing a diameter of 44. Going to hit escape. Oops, slot. I always forget to hit enter at the end there. So diameter 44. All right, and then I'm going to hit escape. I'm going to take this line and this point, and I'm going to shift M, which is the midpoint relationship. Actually, you know what? I'm going to anchor this at the bottom. Let me control Z. Got to take a deep breath here and slow down. This line, and shift M. There we go. And then I'm going to jump into my dimension command and create a dimension from arc tip to arc tip. And that dimension is going to be dimension here from arc tip to arc tip. And that dimension is going to be 450. Going a little too fast, making a few too many mistakes. I think I'm a little shooken up about that mistake about the 5 millimeter diameter. So just got to shake it off a little bit here. Hit the green check mark, shift N, and we'll call this one rear support sweep path. And then we're going to go right plane, begin a sketch, S key, circle, single click here on the origin, move our mouse, single click, let go of our mouse, 5, enter, and then that would be the rear support sweep. Do a Control C here. Shift N, rear support sweep profile. Always good to rename your features as you're going through and modeling in any CAD system, not just in Onshape. But what makes this nice is that now I can choose the sweep path here as my first sketch, and then, sweep profile here as my first sketch, and then the sweep path here as my second sketch, and kind of rip that thing around. Probably running into an issue because that line is solid. Let me just make that line construction and see if that cures it. There we go. That's what we needed. So now we need to create a new plane, and this new plane here is going to be for the center of our, I guess we don't really need to create a new plane. We can just add a dimension, right? So we need to create a new sketch here on the right plane, and then that just needs to be 5 millimeters over. So for a sketch like this, where you've got a lot of curves in it, what I'm going to typically do is kind of start with what I know and get that geometry in place. So I'm probably just going to start by sketching this lower part of the sketch, and then I'm going to come back and get that upper part of the sketch. So I'm going to start out here by going to the right plane, beginning a new sketch, and then press the letter N to get normal 2. And then I'm going to sketch some geometry here, like a line that comes down like so. Single click, move my mouse away from that line, come back, touch the end point, move my mouse away with a radius, single click, and make that radius 15, enter, and then move my mouse away from there and just kind of get a tangency relationship, single click, and then I'm going to type in that distance, which is 26 for that kind of flat area on the bottom there. I'm going to hit escape, and then I'm going to add a dimension here to lock in at least this geometry. So a dimension of 5 millimeters from the origin over to the center of that line, dimension here for the angle, which is going to be an angle of 70 degrees. And then I can take this dimension from here from the front view, which is, let's see here, this dimension here, 18 millimeters, and that's going to be the location here of the center of that ball, which is also the end point of that sweep. So I can grab that 18 dimension to kind of fully lock down this sketch. So we go here, dimension, here we go, from maybe the plane or from the origin to here, 18, and that fully locks down that part of the sketch. So now if I go to the line command again, now I can finish off the top part of the sketch. So you're kind of like discretizing the sketching process, where you're saying this is kind of a complicated sketch and I don't want it to start getting all like wound up with itself and erroring out or anything like that. So I'm just going to do the lower part first, get that all locked down, and then I'm going to move on and do the upper part. And that's a good strategy when you have sketches that start to get complicated, especially with a lot of tangent arcs. So what I can do here is I can maybe take this point and just move it up, just kind of drag it up a little bit, just eyeballing it up here with the sketch. It is pretty close to the top of that. S key line, single click this endpoint, move off, move back, move off again, and single click, and that one's going to have a radius of 20, enter. Come off here with a straight line. You can see here that we've got a straight line here. It looks like it's got a distance of 12.512. I'm not going to type in that dimension, but I'll at least kind of get that line close to that length. So left click, move away, come back, touch the end point, move away again. I'm not clicking anything. I'm just holding my mouse over the end point. Left click here. That one's going to have a radius of 60. And then finally, there's going to be another straight section here that is tangent, and that's going to have a tangency of 20, or a length of 22. So if you just take your time and you kind of pick up on the automatic relations and use some automatic dimensioning, you can really kind of streamline the process of sketching. So now I'm going to go in here to dimension, and for the dimensions on this thing, we're going to have a dimension that goes from that bottom end point to this top end point. And that dimension is going to be 124. We're going to have an angle dimension that goes from this vertical line to this line here, 110 degrees. And we're going to have an angle dimension that goes from this vertical line to this line up here, and that angle is going to be 40 degrees. And then finally, we're going to have a distance dimension from this vertical line to this end point here, and that distance dimension is that 64.5 millimeters. So that gives us the sweep profile for that hook shape. And now that we've got that geometry, we're ready to turn that into a path. So we'll call this one hook path. And then we can make a new plane here. Now in Onshape, you can make a new plane perpendicular to the path at the endpoint pretty quickly. You can pick this path, you can pick this point, you can press reference geometry plane, or just click the plane command, or what I usually do is S key plane. And then Onshape automatically picks up on point normal or point curve. So it's going to give me a new plane here, normal to that curve at the point. Hit the check mark, pick that plane, S key, begin a new sketch, S key circle, single click that endpoint, move our mouse, single click 5, enter, exit that. And that one's going to be called hook profile. And the reason this is helpful is because now when we jump into the sweep command, we can choose a sweep command and we know that the profile goes here, the faces or sketch regions to sweep. That's going to be the profile. And then we can click down here in the path box and we know that the path goes here, and boom, there is our preview for that hook. That thing is looking pretty darn good. And so now we can hit the green check mark and we're ready to move on. That did create that hook as a new component. So we have a new part here now. So we've got this first part here in the tree, which is our rear support. And then we've got our second part here, Shift N to rename that one. That is our bent hooks. And now on the bent hooks at the tip and the end here, to each of the tips here, we're going to go pick this face, S key, begin a sketch, S key, circle, and we're going to create a circle here, which is concentric, and that circle is going to have a diameter of 3. We can exit that sketch, and then we can just click right here on that face, and Onshape picks up on the region between the sketch line and the outside. So you don't have to do like an extra convert or anything like that. And that's going to be a remove to a depth of 10.5, enter, enter, and then we're going to do the same thing down here on this side. Pick this face, S key, begin a sketch, S key, circle, single click right here at the center point, move your mouse, single click 3, enter, exit the sketch, and then you can just pick on that region, extrude, remove, and that's going to go down to 10.5 as well. And I just wanted to take a quick break here. We are coming up to the top of the hour, and so I just wanted to say thank you to everybody who tuned in today. I know there's some people who have to leave, who have to go back to work, so I do apologize that we're going to run into overtime just a little bit here, but I did just want to take a moment and say thank you all so much. It's so good seeing everybody in here. I'm going to continue solving this thing, but if you do have to leave and go back to work, I will see you next week on Model Monday Live, and thank you so much for joining us. And so now to continue this thing out, we're going to go back to the right plane. Remember, we had the right plane over here. We can go back to the right plane, and we can begin a sketch here on the right plane. And once we get to the right plane, we can get normal to. Oops, let's get normal to the right plane. We could also do that with like a Shift 4. Shift 4 is your right plane. Remember, in Onshape, Shift plus 1, 2, 3, 4, 5, 6, 7. These are all your standard views. So Shift 4 is your standard right view. So if you ever do like a Shift N and it doesn't orient correctly, you could just try to use that. So now for this shape here, what we're going to do is we're going to maybe show the hook path. So here in the tree, we could show the hook path. And the reason that's beneficial is because now we can pick up on this line here and we can just draw a line that kind of comes straight off of that line like so. And we can also draw a line which goes right along this plane here, or that goes right along this point here. We're going to need both of those. So we can create a line here like this as well. And we can say that we want that line to be collinear to this line here. You can just do that with I. And then you can create a circle that represents your spherical diameter. So the circle here is going to have that spherical diameter of 21. That's our spherical diameter. And then what we can do is we can create a couple of lines, or really just one line here that comes down like so. We can just create this one single line here that comes down like so. And that line is going to have our whole diameter, or it's going to be our whole diameter of 2. It's really our radius, but 2 times 2 is going to get us to our whole diameter there of 4. And so now we can take that whole shape and we can choose revolve. Now, usually when I'm doing a revolve like this, what I do is I press the space bar just to clear my selections, and then I go through and I pick the regions that I want to revolve, and then I click in here for the revolve axis and I pick on this line, and boom, there is that wooden sphere. We just want to remember to say don't merge, and the way you do that in Onshape is you say new. So you say you want this to be a new wooden sphere. And so we hit the check mark, and then we're going to do the same thing down below here. So just kind of a rinse and repeat. We could probably copy and paste that sketch, but that sketch comes together so quickly that I don't know if that's really necessary. I would probably just go to the right plane here and begin a new sketch, get normal to, and then I would do the same thing here. The other way that we could maybe do this would be to convert, but I think it's I don't know. I found that it feels like it's a little bit easier to just kind of trace a line over top. But again, you could probably go either way. So trace a line over top there, trace a line over top here, take these two, press I, go to your circle command, drop in a circle here, which has a diameter of 21 for that spherical diameter. Okay, make sure that these are going either, you can take these up to the quadrant point as well if you wanted that sketch to be nice and tidy. And then we're going to create a line here, which comes down, make sure it's parallel to this line, come down just right to the edge of the circle. And then we could add a dimension on that one to represent that 4 millimeter hole. So we could do that as 2 millimeters and revolve. And again, here what I do usually is I press the space bar and then I pick this region, and then for the revolve axis, I pick this guy here and we say that's going to be new. So we hit the check mark and boom, there is that other wooden sphere. So now that we've got those two wooden spheres, what can we do? Well, we could change the color of them ahead of time. So we could say edit appearance for these two parts and change the color ahead of time so that when we pattern, it picks up on that color. We could also assign a material here. I can't remember if you assign a material, if that gets picked up with the pattern, but we can try it. And this material is going to come from the TooTallToby custom library. Unfortunately, my custom library, I lost associativity to it. So, rather than reestablishing that, I think what I'm going to do is I'm just going to type in a custom density here. So I'm going to type in cherry, and then I'm just going to put in a custom density here, 0.057, or no, 0.570. I think that's going to get me there. And I'll do the same thing with the other parts as well. So right mouse button, assign material for two parts. And then normally I would just access the TooTallToby library, but it's I lost association with it for some reason. So this will be 7.800. And check mark. And I think that now if I go to the pattern command, I'm going to go here to the linear pattern command. If I go to the linear pattern command and I take this part to pattern and this part to pattern and this part to pattern, now I can say for my direction, I'll just choose this plane here. So it kicks off the pattern relative to that plane. The distance is going to be 96. 96, is that what it is? Yep. There's going to be 3 instances, and then this thing is going to be centered. This is something I really like about Onshape. You just choose centered here, and then that pushes it over in the one direction and pushes it over in the other direction. So once we're done with that, if the materials did transfer correctly, we can go here to display mass and section properties, and then we can just window select the whole thing. We can just window select everything here. And we're coming up with a mass here of 320.046 grams. So let's go back into the app and see if we got it right. So let's see here, 320.046 grams, and enter. And oh yeah, we did it. Let's go. Couple of little hiccups there along the way, but we did indeed do it. And that is how you can do it in Onshape. And yeah, a couple of little hiccups there. I know I do again apologize for missing that 5 millimeter wire, but it seems like most of you guys were able to find that one. And also my materials. I got to get my materials back up and running. There is in the website, so you can choose. I'm going to choose submit here. In the website, we use 4 materials. We use 4 different materials for all of the challenges here on the website. So you can always go up to the top of the screen here and go to resources, materials, FAQ, or TooTallToby.com/materials. That's the website, TooTallToby.com/materials. And you can see here, these are the 4 materials we use: plain carbon steel, 6061, ABS, and American cherry. And here are their densities. But as you scroll down here, you'll see there's a lot of resources to help you understand how to capture those materials and add them to your library. So you can always get in here and you can add these materials to your library. There's instructions on how to create custom materials. There's videos. Some people have posted their own libraries. And just recently, if there's any Fusion users out there, somebody in Discord posted an add-in for Fusion to help you select these materials quickly. So this is a lot of fun, and make sure that you get those materials and get them working in your system. And Luca DX says, I followed along with some of the CAD vs. CAD challenges, and I feel like I might be able to compete. Well, you're in luck, my friend. Our next tournament is coming up this summer, so you can absolutely compete. Be on the lookout for announcements. And 3D Wing coming in with a $5 super chat here as we're winding down on the live stream. Thank you, my friend. Very much appreciated. That is awesome. Thank you, thank you, thank you. Always appreciate the super chats rolling in, and very happy to hear that the website and the live streams are helping you out as well. And so what we do here on Model Monday Live is we post a brand new challenge for all of the people in the audience to attempt to do on the website. I mentioned this at the beginning of the tutorial. You can go here, access full library. And when you go into access full library, you can see here that there are these 4 challenges up at the top that you can do and that you can do for free. You don't have to have a paid account to do the featured challenges. And the one that we just posted today during today's live stream is this one here, the one that I just solved. Well, what we've got is we've got this space age technology. You can tell because of the rocket here. You got the space age technology, and you can see here that we can take a look at the first 42, and we can see who finished the model the fastest from when it was released. I released it here on the website at 1:37 p.m. That was about the same time I showed it to all of you. And within 7 minutes and 7 seconds, none other than our good friend Dom Linder, rockin' SolidWorks, finished that challenge. Congratulations, my friend. And I noticed that he not only finished the challenge, but he also posted a speed run of himself finishing the challenge in real time. So that is so cool. So if you're curious about how Dom was able to complete that so fast, he did it in 4 minutes, 36 seconds. That time might be a little bit off because that's really like if you click start the clock and end the clock. But he did it in under 7 minutes from the time it was released. And here is a video showing how he did it. So very, very cool. Or maybe he went back in and did a second speed run. Who knows? But very, very cool. And congratulations, Dom is going to earn the second point of the day. Followed up here by Gray from Russia, rocking SolidWorks. Koska from Latvia, rocking Onshape. We've got Ustrel from Spain using SolidWorks. Very nice. We got Likud. We saw him in the chat just a few moments ago. Not sure what CAD system you're using, but did it in 24 minutes from the time it was released. Very nice. We got Uncle Facepound here in the Onshape crew down at the bottom. 25 minutes and 25 seconds. And then finally, bringing up the caboose, TooTallToby, 26 minutes and 6 seconds. So very, very cool. That is awesome. And that is a lot of fun. And congratulations to everybody. Oh, and somebody else just finished it as well. Let's see who else came in here at the end here. H11R from Indonesia with free CAD. Yo, that is awesome. And guys, as always, you know, I love doing these kinds of challenges. I love doing these real world challenges, real world stuff. And I got to tell you, there's kind of a backstory with this one. I just wanted to share with you real quick here. Normally what I do is if I'm out and about, like we were at the first aid meet this weekend for the scouts, and I saw a coat hanger like this hanging up. And normally what I do is I take photographs, and like I happen to know that my hand is almost exactly 100 millimeters wide. So sometimes I'll put my hand next to the photograph, and that way like I can kind of get the scale to be more or less correct. But it's always difficult. You have to get it from one angle. You have to get it from another angle. So this weekend what I did was I finally grabbed Scaniverse, which is an app for iPhone, because I do have an iPhone and it's got like a banging camera system in it. So I figured let's use it. And then I just did like a basic scan, and you know the scan came out okay. If you're scanning from a phone, you're probably not going to get super high quality results. Of course, this was under no setup. Like I didn't go in and set it up with like a proper backdrop or anything. I just literally put it on a linoleum floor in a gym and just scanned it just to see if it would work and see how difficult it was. Once I was done with the scan, I was able to text the STL to myself, and then I was able to open that text on my computer. I threw it into a messaging system like Discord, and then I went on my computer and I grabbed that STL and brought it into SolidWorks. And this was awesome. You know, like I know there's some of you out there that are already 3D scanning a lot, but then what I was able to do is I was able to bring it into SolidWorks and do the things I normally do from a photograph. You know, I created a new sketch here and determined what the distance was between those two wooden spheres. I sketched the circle for the wooden sphere to determine the diameter. I sketched the line here to determine what the spacing was. So I still recreated the model from that original scan geometry. But the thing is, it's so much easier to work with that scan geometry and use that to reverse engineer the model into a SolidWorks model than it is to do it with the photographs. And so, you know, just keep that in mind. If you're out there, there's plenty of free scanning programs that you can get on your phone. And if you're ever out and about and you see a cool model that you would like to model up in 3D print or something like that, you know, you're almost certainly not going to go from the scan to the 3D print. But what you could do is you could scan it in and then reverse engineer it by creating your own sketches and features. And that is a really, really cool thing that we can do nowadays. You know, you could be anywhere and just pull out your phone and then scan the thing that you want to model up, that you want to 3D print. And I think that's really cool. And that's the first time I did it. I'm going to keep doing it, and I'll keep showing you guys the results as I get better and better and learn more of the different techniques. But this was literally my very first attempt, and I have to say it was indeed a success. And I think that's pretty cool. So, guys, as always, thank you so much for joining us today. I'm so happy that the weather is breaking. I'm so happy we get to be outside a little bit more, outdoor practice this week. So make sure that you spend some time, get outside. Congratulations to Dom for earning that second point. Congratulations to Hassan for earning that first point. That is absolutely awesome, and you guys will be on the leaderboard by next week. Thank you all so much to the chat. I will very much look forward to seeing all of you next week in Model Monday Live. And until then, I just want to say thanks for helping me start the week on a high note. It's always such a fun way to start the week here in Model Monday Live to hang out with all of you. So I hope you all enjoy the rest of your Monday, and I hope you all enjoy the rest of your week. And I will see you in the next TooTallToby live stream. See you, everybody.